Good afternoon. Can you guys hear me?
Yes.
All right. I am going to start the class for today. I want to tell you that last class period, I noticed at the middle of the meeting, the slides are not moving. So I had to go back and redo most of it. And I have corrected that and put that Zoom meeting 19, last Zoom meeting, go back and watch it again. Could you help me out? If the slides are not moving, please let me know immediately. That will help me to correct that right away. All right. I am going to share the chapter 5 slides and continue the class for today. Do you have any questions?
No.
All right. All right. Can you see my chapter 5 slide on instructional objectives?
Yeah.
Okay. I am going to talk about what we've done so far. We were on chapter 5, describing gases, liquid, solids in detail. We described the physical state based on kinetic molecular theory, physical states of gas, liquid, and solids. Then we went on to describing gases first. First, we talked about how the pressure is measured for gases. Then we described the gas behavior of gases using changes in pressure, volume, temperature, and amount of substance measured as moles. There are gas laws that we use. There are 6 gas laws: Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, ideal gas law, and Dalton's law of partial pressure. We did calculations using each one of these gas laws. So you should be able to write them down and do calculation after identifying the variables that need to be plugged in and solve for unknown variables. Dalton law of partial pressure, we also did some calculation. Then we went on to describe intermolecular attractive forces and compare that to kinetic energy of particles making up the matter. Kinetic energy is disruptive force, intermolecular force is cohesive force. There's a balance between these two when the gas becomes liquid and liquid becomes solid. We look into that, the balance between disruptive force and cohesive forces of intermolecular attraction. There are 3 types of intermolecular forces: hydrogen bonding, dipole-dipole interactions, and London dispersion. The weakest is London dispersion, then dipole-dipole. Strongest is hydrogen bonding. We talked about how these forces affect the behavior of different states at the molecular level. We went on to describing liquid state using kinetic molecular theory. We looked into boiling point of a liquid, melting point, vapor pressure, viscosity, and surface tension. We go over this. Now we describe the melting, boiling, and evaporation and condensation of liquids. Today, we are mainly going into solid state. We're going to define phase changes using cooling curves and heating and cooling curves and phase diagrams. So that's the last topic of the chapter 5. So I am going to go to solid state right away. A solid state is the state where the particles have lowest kinetic energy, lowest disruptive forces. As the substance is cooled, it reduces the velocity of particles because the kinetic energy become lower. So as the kinetic energy become low, intermolecular forces, attractive forces can overcome the kinetic energy. Therefore, particles come close together and stay in fixed position. Random motion stop and solid is formed. Normally, we call this solidification. Liquid becoming a solid is called solidification. We also use the term crystallization. I was trying to write down on here. Crystallization is when the crystals are formed. Normally, most of the time, when a solid is formed, crystals are formed. But there are instances, there are times that solidification doesn't involve crystallization. Only solid is formed. This solid don't have a structure like crystalline structure. Therefore, it's called amorphous. I am going to talk about amorphous and crystallization, how we differentiated that in the solid. Let's look at types of solid. There are 6 kinds of solid. First one is ionic solid. Second one is molecular solid. These are mainly ionic compounds. Ionic solid are formed by ionic compounds. Ions are found in the crystalline lattice. They are mostly crystals. They are high melting. Examples are like salt, table salt, sodium chloride, and the potassium sulfate. Molecular solid, on the other hand, are formed by covalent compounds like water, which has a crystalline lattice, ice. They are lower melting point. Examples are ice and aspirin. The third type of crystalline solid is polymeric solid. Polymeric means they are repeating units. They can be crystalline or semi-crystalline or amorphous. Mostly amorphous. Polymeric compounds are mostly amorphous. Crystals are not formed. They are low melting. They could be soft or hard. For example, polymeric materials are rubber, plastic, and protein. Protein are made out of amino acid, units of amino acid. Those are mainly, polymeric material are mainly amorphous. Network is formed by connection between atoms in three-dimensional space, like in diamond here, diamond and quartz. Diamond has carbon atoms connected in the three-dimensional space by carbon-carbon atoms. Therefore, they are very hard. Diamond is the hardest material solid that we can find. We use it to cut many other solids using diamond. Quartz is a silicon and oxygen compounds that are found in gems. Diamond also considered as gem. Graphite is also a network solid. It has carbons in hexagonal arrangement with layers. It's different from diamond, but it is a network. Most of the gems are network. The fifth material is amorphous. There are solids where the atoms and molecules are not arranged in a regular order. They are randomly distributed. They are soft solid, and they can be made to flow, but have no fixed melting point. For example, in your fireplace, when you burn wood, the soot found in the fireplace is amorphous carbon. Tar is also amorphous. So is the glass. Glass is not a crystalline material. It is a semi-solid liquid. How do you make glass? Is you heat up silica, SiO2, and create the liquid, and then slowly cool it off to form layer glass sheets. They are still semi-liquids. There's no crystalline structure. Therefore, they are considered amorphous. The last sixth type of solid is metallic. Metals, there are so many metals in the periodic table. They have free electrons in the metallic solid called electron clouds. Therefore, they show conductivity. Conductivity of electricity, thermal conductivity, is one of the characteristics of metallic compound. We talked about that when we talked about metals. They could be soft or very hard. They are low melting or very high melting. Some of the metals can be formed to sharp objects. Therefore, a lot of weapons are made out of metallic compounds. So these are the six types of six types of solids. You should be able to identify them if a compound is given, looking at the formula. If it is ionic, it's ionic crystal. If it's molecular, it's molecular crystal. Polymeric, made out of several units of polymers, like rubber. Network is mainly diamond, quartz, and graphite. Amorphous is carbon, glass, and tar from petroleum industry. Metallic is metals and alloys that have special property of conducting electricity. Which is a molecular solid? We are going to go through some problems. Which is a molecular solid? We talked about molecular solids are the solid that contain molecules. If you look at this, magnesium chloride is ionic solid. gold is metallic, glass is amorphous, graphite is network. The sucrose is the only one that has molecules. Sucrose is sugar, common sugar. Answer is molecular solid is sucrose. What is an ionic solid? First one is potassium chloride. That's an ionic compound. Therefore, it's an ionic solid. Copper is a metallic. Choice SiO2 is that's quartz. Quartz is network. Rubber is polymeric. Polyethylene is polymeric. Therefore, only ionic solid is potassium chloride. A. What is a network solid? We talked about network solid. Diamond, graphite, quartz. So sodium bromide is an ionic compound. It's not a network. Silver is a metallic compound, metallic solid. Network is quartz, silicon dioxide here is the network. Sodium is metallic, sucrose is molecular. Therefore, answer to 267 is C. Let's look at what applies to freezer drying. When you freeze dry, what you do is you freeze the food and the water in the food become ice. And then when you're drying it out, you remove water vapor from the ice. Solid to gas is sublimation. Freezer drying processing include solid being converted directly to gaseous water, ice to water, gas. That's true statement. The statement all solid are crystalline solid is not true because some of the solids are amorphous, metallic, semi-crystalline, therefore it's not the true statement. False. Polypropylene is a typical plastic. It's an example of amorphous solid. That is correct statement. True. Sodium chloride has higher melting point than sucrose. Normally, ionic compound. This is ionic solid and molecular solid. Ionic solid have higher melting points than sugar has lower melting point. Sodium chloride, salt. If you put in heated container, if you heat sodium chloride, salt, it won't melt, but the sugar will melt and make caramel. If you heat regular sugar, it becomes caramelized. That's the true statement. Condensation is the opposite of sublimation. Condensation is gas to a liquid. Sublimation is solid to a gas. Therefore, it's nothing to do with condensation. So this is false statement. We're going to look into these physical changes, condensation, sublimation, in next few slides. Graphite is an example of what kind of solid is graphite. We talk about graphite being network solid. The blank is network. Now we going to talk about phase changes and energy changes. What is a phase? If you look at water, there are 3 different phases. Water has 3 different phases. One is gaseous, steam. water, liquid phase is called water. Solid phase is called ice. So there are three different phases for many substances. I described that. Solid water is called ice. Liquid water is called water. Steam is gaseous water. A phase change is the change of phases, ice to water, water to gas. A change is called phase change. When a phase change takes place, normally the temperature doesn't change. Temperature stays the same. Do you guys have a question? Okay, we're going to look into phase changes and energy changes when the phase changes take place. Normally the phase changes are associated with, can you see my slides?
Yes.
Okay. We're going to look into phase changes. Normally the energy associated with particular phase, amount of heat absorbed during the phase change, is calculated by this equation. Specific heat of the phase, that one, multiplied by m. M is the mass of the material, mass of the phase. Final temperature is T2 minus T1, temperature change. Final minus initial temperature. So if you look at the phase changes associated with water here, energy required to heat 1 gram of solid water at minus 20 degrees Celsius to 122. There are 5 steps in here. You start from ice at minus 20 degrees Celsius and heat it up to 0 degree. So ice absorbs heat. Nothing happened to ice until it reaches 0 degrees. To change the temperature from negative 20 to 0, you have to provide heat 9.6 calories. How do I get 9.6? 0.48 multiplied by 1 gram multiplied by temperature change is 20. 0.48 multiplied by 20 is 9.6. That's how you calculate energy. Energy is absorbed to heat the ice from negative 20 to 0 degrees Celsius. Now from 0 degrees Celsius, we start to melt ice. So when you melt ice, it's a phase change. When you heat ice, it's just heat in the ice. Melting is a phase change. Melting is solid become liquid. Can you see my slides right now? Can you see phase changes and energy?
Yes.
Okay, I want to make sure that it's been shown in your screen. The melting ice is a phase change. Solid become a liquid. Then third here, warming water from that's not a phase change. That's the specific water, heat of water is given 1. So 1 times temperature change is 100. That's 100 calories. Now the boiling water is phase change. Boiling water is liquid to gas. Therefore 540 is same as heat of vaporization. So after we converted all the water to steam, we start heating steam 100 to 120. So temperature change is 20 degrees. Therefore, 0.8 specific heat of steam multiplied by 20 become 1.9. So this is the kind of a changes associated with water, that how you calculate. This same thing could be shown in a heating curve. If you look at this A to B, that is ice, 0 degree, minus 22. That's heating ice. When the melting takes place, temperature doesn't change. This y-axis is temperature, x-axis is heat added. In a heating curve, x-axis is heat added. When you're heating, you're adding heat. So when the phase change takes place, melting or boiling, melting is B to C. D2 is boiling. When phase changes take place, it doesn't show up in the temperature. It is the energy that provides to overcome the attractive forces of the solid when it becomes a liquid, or liquid become a gas, to overcome liquid forces, particle forces attracting liquid to break it up. That's a hidden energy as a substance is heated. Cooling curve is the opposite of, if you put a mirror next to temperature axis, y-axis, you will get a reflection of this curve called a cooling curve. This is exactly reflection of that other graph, but the diagram is a little different. They're showing the solid ice and liquid and the gas steam here. Now, liquid substances could have a cooling curve, heating curve. You should be able to identify if something is cooling curve or heating curve. Also, where the horizontal line, where condensation is a phase change, in this diagram, X to W is phase change. C to Y also phase change is freezing. Freezing is when you heat, it's removed. The liquid becomes a solid. It's called freezing. When the gas becomes a liquid, it's called condensation. That's a phase change shown up in W to X points. The cooling curves show how a substance temperature changes as heat is removed. Temperature, how the temperature changes. You start with the highest point where the steam is at the point V, and it come down to W, and then stay the same between W and X, then drop down. So these points where it is line is not horizontal, that is a heating of the particular phase. V to W is heating of steam, cooling of the steam. X to Y is cooling of a liquid. Therefore, you can identify phase changes from heating particular phase. Summary of phase changes. We need to understand phase changes and know what exactly going. If you have three phases, mainly we have three phases. If you look into changes between these three phases. There are solid to liquid equilibrium. This arrows going back and forward and backward, shows solid go to liquid or liquid could go to a solid. So is liquid can go to gas or liquid. Gas can go to liquid. Or the bottom lines are solid to a gas, gas to a liquid, gas to a solid. So these arrows have a specific term. When solid goes to a liquid, is called fusion or melting. Heat is required to melt or fuse a solid. Therefore, it's endothermic. Endothermic means heat is required. When a liquid is going to a solid, it's called freezing. It's exothermic. Heat is released. Liquid has higher kinetic energy than solid. Therefore, heat is released when liquid goes to solid. So, other phase equilibriums, there are three phase equilibriums. One is fusion and freezing. Liquid to gas equilibrium is evaporation. Is liquid to a gas is endothermic, absorb heat. Then gas to a liquid is condensation. That is exothermic. The bottom change in the equilibrium is exothermic, and top term in the equilibrium as shown is endothermic. Absorb is endo, exo means release. The solid to gas equilibria are sublimation and deposition. Solid going to a gas is called sublimation. Gas going to a solid is called deposition. There are 6 types of phase changes shown here. Fusion, freezing, evaporation, condensation, sublimation, deposition. Each these 3 are tied up with the fusion and freezing is take place opposite direction to each other. Evaporation and condensation is opposite direction to each other. Sublimation and deposition is opposite to each other. So changes, phase changes in the bottom of the are called exothermic. Endothermic is the fusion, evaporation, and sublimation. Endothermic means requires addition of heat to solid to become a liquid, liquid to become a gas, or solid to become a gas. Sublimation requires energy, heat. Exothermic is heat is released. Normally, heat is released when a gas goes back to a liquid. Gas has kinetic energy, higher kinetic energy. Higher kinetic energy is higher temperature. If something goes from higher temperature to lower temperature, it's a release of energy. Heat is decrease means release. So we have some questions here. Sublimation and deposition are opposite of changes of state. Sublimation and opposition are opposite of changes of state. That's not true. That's true. I'm sorry. I didn't read the question. Sublimation is the third phase equilibrium. Solid going to a gas is deposition. Solid going to a gas is sublimation. Gas going to solid is deposition. So therefore, that's a true statement. A pure solid substance is heated as indicated in the diagrams below. First is a heating curve. Second is the same curve is a cooling curve. The question you asked is related to these diagrams, heating curve and cooling curve. Which portions of the graph is only when a liquid is present? The liquid, this A is here is a solid. B is a melting or fusion. C is a liquid being heated up. Therefore, answer where the liquid is present is C. If I ask you where the steam is present, it's going to be E. Where the ice is present or solid is present, it's going to be A. What is the fusion, phase change of fusion is B. D is evaporation or condensation. So answer to number 289 is C. I gave you all the points. You have to pick up where the liquid is present is C. Graph indicate the solid-liquid equilibrium. Solid-liquid equilibrium is the B. That's A is the solid. And the horizontal line B is the phase change. Solid is converted to liquid. Therefore, B is the correct answer. In both diagrams, which are identical, it's a reflection of other cooling and heating curve. So B is the correct answer for which one. So phase changes are equilibria, like solid liquid. B is the correct answer for 290. 290 on. The graph indicates the boiling point. Boiling point is where the liquid to gas transition takes place, phase change. That is D, boiling point, where it stays same, horizontal line D. D is the correct answer. We're going to look into phase diagrams. Phase diagrams are diagrams which summarize a lot of information. More information than cooling, heating curves. They are more detailed. If you look at the phase diagram of water, it's a diagram where y-axis is pressure, millimeter mercury, x-axis the temperature, where the scales are kind of reduced. They are contracted here. Scale is greatly reduced, squeezed. Phase diagram has pressure and the temperature. One of the things you can say for sure in a phase diagram, there are three regions for solid, liquid, and gas phase. Vapor is water, vapor is gas. The area next to the y-axis or the pressure axis is the solid. In between x and y-axis, the middle area is called liquid phase, where liquid phase exists. And the area next to x-axis is the gas phase. There are solid, liquid, vapor phases. There are boundaries between gas phase, liquid phase. For example, A, DAC, DAC. DAC is representing vaporization, condensation, or sublimation if it is directly converted to solid is converted to gas is called sublimation. You could be asked questions like this. What temperature is the water boils? We go to 762 on the pressure and goes down where the water melts is the point B downward. Then you can see it reaches where the 760 is reached on the AB line. If you go down, it's a 0 degrees Celsius. You can tell what is the melting point of water. Then you can show where the boiling point of water is the normal boiling point, normal freezing point on the line drawn at the 760 762 is the atmospheric pressure. So line going down from C reaches the temperature axis at 100. You can tell what temperature it is boiling. There are a few other things. A triple point where all these three lines, D to A to B, A to C, meet is called triple point. That's the point all three phases can exist simultaneously. Normally we deal with two phases at a time. D to A is a phase change between gas and solid. So it's called sublimation or deposition, subliming deposition. If you have a point on AC, is melting, is vaporization or condensation. If you draw a line where E to F on the top of the top right corner of the graph, there's a E to F, E to H, E to G. If you change the temperature from E to F, its only temperature is changing. That means cooling. A gas goes to a liquid. So eventually you end up, if you change the temperature from E to F, it's freezing. If you change from H to E, it's melting. Liquid goes to, it's vaporizing. Liquid goes to a gas. So this line crosses. AC line is crossed by line H to E. So you can say so many things about that, about the compound's behavior. Now, one more thing you need to understand is in lower atmospheric pressure lower than 760, if you go down the temperature at high elevation, normally water doesn't melt, ice do not melt. In high elevation, ice is sublime because it's lower atmospheric pressure. So you can tell so many things from the phase diagram. Each substance have its own phase diagram. For carbon dioxide, this phase diagram is different. Its boiling point is at 73. Temperature is boiling point is temperature. Boiling point is liquid to is here. if I ask you what is the boiling point of carbon dioxide, that middle line here is about negative something. It's not normal pressure. 73 is very low pressure. So when you, this is the boiling point of carbon dioxide. But anyway, features are the same. Solid phase is in the area next to the pressure y-axis. Gas is next to the temperature axis. Liquid is in between. So therefore, a lot of things could be summarized. Let's answer these questions. Then we are done. 3 of the 4 phase changes below are endothermic. Which phase is not endothermic? If you look into this, vaporization is endothermic. Sublimation requires energy, endothermic. Condensation, normally gas going to a liquid, is exothermic. Melting is solid to a liquid, requires energy. A, B, D are endothermic. Only exothermic one is not endothermic, is exothermic. D, C is the correct answer. Condensation. Which of the following pairs of physical chains are both exothermic? Sublimation is endothermic. Evaporation is endothermic. Freezing is exothermic. Melting is endothermic. Freezing is exothermic. Condensation is exothermic. Melting is exothermic. Sublimation is endothermic. The one that I so far got was C. That's the correct answer. Which phase changes below is endothermic? Deposition is exothermic. Gas becomes solid. Melting is when something is melting, you need to solid to a liquid. Therefore, it's endothermic. Condensation is exothermic. Freezing is exothermic. Only correct answer we got endothermic is melting. Which of the following pairs of state changes is the final state? Is the same for both members. Final state should be same. Sublimation and evaporation. Sublimation goes to a gas. Evaporation goes to a gas. Both members are pair. Same final state. Sublimation goes to a solid. Evaporation goes to a gas. It's not the same state. Condensation goes to a liquid. Freezing goes to a solid. It's not. Deposition goes to a solid. Melting goes to a liquid. Sublimation is solid to a gas. Solid to a gas. Evaporation is a liquid to a gas. Therefore, same final state is A, sublimation. That's the correct answer. For an endothermic change, select the name of the change of state from the response. Endothermic change. Sublimation requires energy. Therefore, it's endothermic. Condensation is exothermic. Deposition is exothermic. Freezing is exothermic. To freeze, endothermic. and select the name of the change of the state from the reference. Sublimation is when something is endothermic. Condensation is exothermic, gas to a liquid. Deposition is gas to a solid. That's exothermic. Freezing is liquid to a solid. Endothermic is sublimation. A is the correct answer. For the chain that is opposite of evaporation is what? Condensation. This is easy question. Opposite of evaporation is condensation. Opposite of deposition is sublimation. So for this evaporation is the condensation opposite, B. For every energy, for a change where energy is absorbed, select the name of the change of the following. Energy is absorbed. That means endothermic. Sublimation is endothermic. Condensation is exothermic. Deposition is exothermic. Freezing is exothermic. Sublimation is the correct answer. Okay, let's do the final question. For a change that does involve liquid-solid state, liquid and solid state, select the name of the change of the follow for the state of the response. Changes in liquid and solid state. Liquid and solid involve in freezing only. Sublimation is solid to a gas. Condensation is gas to a liquid. Therefore, freezing is the correct answer. Liquid to a solid state is freezing. Answer is D. For change that involve both liquid and gaseous state, select the change from following responses. Liquid and gaseous state, condensation and vaporization. Condensation is the only liquid state, liquid and gaseous state, condensation. Vaporization is not given, so therefore answer is B. On which portion of the phase diagram only a liquid is present? On the diagram on the right side, liquid is present at Y. Y here. Liquid is at the middle. Therefore, liquid is Y. Answer is D. When a change is take from E to F, E is in the solid, F is in the gaseous phase. Solid to a gaseous phase is solid gone to gas is a sublimation. A is the correct answer. Which portion of the phase diagram is the triple point? I said the point where all the three lines meet here, the point A is the triple point. A is the correct answer. For a chain that involves both liquid and gases, select the name of the change from the liquid and gaseous state. Liquid and gas is condensation. That's B. Popcorn pops because the difference of density of the gaseous water. That is why popcorn, when you put in the microwave, when you heat it up, there's water in there. Density of the liquid gas between liquid gaseous water is in the popcorn. They become gaseous. From liquid to it pops. That's how we want. That's the truth. I am done with the chapter 5. Do you guys have any questions? Do you have any questions? I'm going to stop the share here. I will see you guys on Tuesday. Are you guys there?
Yes.
All right. Have a nice weekend. Okay.
You have a good
Yeah, you too.